I want to be a forensic scientist because it involves stuff like maths and biology, which are my favourite subjects. And I'd like to do something that involves them. It's just something that's always interested me, really. Instead of like being a doctor where you have to do a specific thing, which is really helping people and saving them. Whereas in the forensic science, it's like you get to do experiments and see what happened and how things happened.
The start of forensic science is the crime scene, and at the crime scene, unfortunately, you usually have a body. The first thing we do is visually look at the body and determine what evidence or what information we can get. One piece of information that's important is the temperature of the body when you see it, particularly the inner core temperature, which allows us to then relate that to the time that has passed since the person was living. What's the temperature, Caris?
70 degrees Fahrenheit.
The normal temperature of a living body is 98.6 degrees Fahrenheit, so this body is significantly cooler, which means it's been deceased for a period of time.
And how do we figure that out?
We use an exponential relationship based on Newton's law of cooling, which allows us to graphically look at time and temperature and determine how much time has passed since the person was living.
On one axis of a graph there would be different temperatures of a body, and on another there would be the amount of time. And you'd measure it, whatever the temperature was, there would be a certain point for what time, like how long ago the body had been deceased.
You measured the temperature of the corpse at 70 degrees Fahrenheit. We can use that to show that the starting temperature of living is 98.6 degrees Fahrenheit, and then you have a decline post-mortem until you get to the 70-degree axis, and then you can follow down to the x-axis, which shows you around 5 hours have elapsed since death.
So where else do we use maths in forensic science?
If we were back at a crime scene and there was blood spilt out with a body, then we can look at the blood spots and try and determine the angle from whence they came. You can see you have a typical teardrop-shaped spot of blood there, which means that the blood came at an angle less than 90 degrees.
We measured each blood droplet, and with those measurements we used trigonometry to find the angle that it impacted, and then got a protractor and a piece of string and seen exactly where the blood would have come from.
So the final thing we can do at a crime scene is to determine whether any substance is present in the blood, and we do this by measuring the absorbance of that substance. So that involves this instrument here. So if you would like to put the cuvette of our sample into the instrument, you'll see immediately that we get an absorbance reading. It's positive, so it means that something is definitely there, and then we can work out the exact concentration using a calibration curve.
Put a specific substance into the instrument and you get a reading from it, and then you take the reading to a graph, and the graph shows you how much of the substance has been absorbed into the blood.
We can then take our unknown value and read that along to the curve and then down to get its concentration.
Yeah, I still want to be a forensic scientist because after having a taste of what you do, it's interested me more than what it was before I knew exactly what you did. And I really enjoyed it because it was like really hands-on and practical, and it had a lot of the stuff that I really enjoy doing.